Section 9.3, Systems of Linear Equations, Solutions by Addition. Objectives: use the method of addition to solve systems of linear equations. To solve a system of linear equations by addition, our procedure is step 1, write the equations in standard form, one under the other, so that like terms are aligned. Standard form is ax plus by equals c. Step 2, multiply all terms of one equation by a constant and possibly all terms of the other equation by another constant so that two like terms have opposite coefficients. Step 3, add the two equations by combining like terms and solve the resulting equation, if possible. Step 4, back substitute into one of the original equations to find the value of the other variable. It is important to always go back to your original equation, because if you've made some type of an error in manipulating your original equations, back substituting into the original equations is going to help catch that for you. Finally, check the solution, if there is one, in both of the original equations. And again, notice original. Example 1, use the method of addition to solve the following system of linear equations. X minus y equals -1, 2x plus 3y equals 33. Those are both already in standard form. You'll notice my x's align and my y's align. And my goal is to turn the coefficients, which were the numbers in front of the variables, into the same number with opposite signs. And there'll be lots of options with these typically. Our solution will be to multiply each term in the first equation by 3 and leave each term in the second equation as is. Now the y coefficients will be opposites, and the two equations by combining like terms. This will eliminate y, and we'll be able to solve for x. So here you can see we take that top equation, and we take the entire thing times 3, which is going to give me 3x minus 3y equals -3. Every piece, the x, the y, and your constant term on the other side of the equal sign. And then all I did here in that second step is just to rewrite that second equation right underneath the first. 2x plus 3y equals 33. Now I'm going to add these two equations together. When I add these together, the -3y and the 3y add to 0, which leaves me with 5x equals 30. When I divide both sides by 5, that gives me x equals 6. Now I'm going to substitute x equals 6 into either one of the original equations. So I can do that in x minus y equals -1, or I can do it in 2x plus 3y equals 33. I'm going to walk through in both. When I plug it in on the left, that gives me 6 minus y equals -1. When I plug it on the right, 2 times 6 plus 3y equals 33. All right, when I simplify the left, I get -y equals -7. When I simplify on the right, I have 12 plus 3y equals 33. On the left, I end up with y equals 7 because I've divided both sides by -1. On the right, I'm going to have one more step because when I simplify things by subtracting 12 from both sides, that only gives me 3y equals 21. So I have to divide both sides by 3, which gives me y equals 7. But you'll notice either way, I ended up with 7 as my y coordinate when I plugged in 6. So the solution is 6, 7. And substituting shows that 6, 7 satisfies both of the equations in the system. X minus y equals -1, 2x plus 3y equals 33. So plugging in the 6 and the 7 on the left, does 6 minus 7 equal a -1? And on the right, does 2 times 6 plus 3 times 7 equal 33? On the left, I get -1 equals -1. On the right, once I multiply, I have 12 plus 21. Does that equal 33? Yes, it does. So it checked in both. Example 2. Use the method of addition to solve the following system of linear equations. 3x minus 1/2 y equals 6. 6x minus y equals 12. We're going to multiply the first equation by a -2 so that the y coefficients will be opposites. So again, I'm taking -2 times everything in that first equation. -2 times the 3x gives me -6x. -2 times the -1/2 y gives me a positive y. Negative 2 times 6 gives me a negative 12. And then I just rewrite 6x minus y equals 12 underneath that one. Now I'm going to add those together. That gives me 0 equals 0. So you'll notice in this case, the x's and the y's both were eliminated. Now I have to evaluate what kind of a solution 0 equals 0 is. Well, since 0 equals 0 is always true, the system has infinitely many solutions. The equations are dependent, and the solution set consists of all points that satisfy the equation 6x minus y equals 12. Solving for y gives y equals 6x minus 12, and we can write the solution in the general form x comma 6x minus 12. Or if we had decided to solve for x, we could write the solution as 1/6 y plus 2y. Example 3, use the method of addition to solve the following system of linear equations. 2x minus 4y equals 1, negative 3x plus 6y equals 2. We're going to multiply each term in the first equation by 3 and each term in the second equation by 2. This will result in the x coefficients being opposite. So in this case, we had to multiply both equations in order to get this to work. And that happens sometimes. When I multiply the top equation by 3, 3 times 2x gives me 6x, 3 times negative 4y gives me negative 12y, 3 times 1 gives me 3. So I have 6x minus 12y equals 3. When I multiply 2 times the bottom equation, 2 times negative 3x is negative 6x, 2 times 6y is 12y, 2 times 2 is 4. So my second equation becomes negative 6x plus 12y equals 4. And again, when I'm looking at these, I'm adding together, and I'm thinking, this time they both added to 0 on the left again, but this time I have 0 equals 7. That's not a true statement. Because the last equation, 0 equals 7, is false, the system is inconsistent and has no solution. Example 4, use the method of addition to solve the following system of linear equations. X plus 0.4y equals 3.08. 0.1x minus y equals 0.1. We're going to multiply the second equation by negative 10 so that the x coefficients will be opposites. I'm just going to rewrite my top equation. X plus 0.4y equals 3.08 is 1x plus 0.4y equal 3.08. I'm going to multiply that second equation times negative 10. Negative 10 times 0.1x is 1x. Negative 10 times negative y is positive 10y. And negative 10 times 0.1 is negative 1. Now I'm going to add those two equations together. And in this case, the x's are eliminated because they add to 0. I'm left with 10.4y equals 2.08. I'm going to divide both sides by 10.4, which gives me y equals 0.2. I'm going to substitute y equals 0.2 into one of the original equations. In this case, x plus 0.4y equals 3.08. X plus 0.4 times 0.2 equals 3.08. X plus 0.08 equals 3.08. I'm going to subtract the 0.08 from both sides. That's going to give me x equals 3. So the solution is 3.2. To check, I'm going to substitute x equals 3 and y equals 0.2 in both of the original equations. I'll let you do that. Example 5. Use the method of addition to solve the following system of linear equations. 3x plus 5y equals negative 3. Negative 7x plus 2y equals 7. For this solution, I'm going to multiply each term in the first equation by 2 and each term in the second equation by negative 5. This will result in the y coefficients being opposites, and the two equations, by combining like terms, will eliminate y. Solve for x. 2 times my top equation is going to be 2 times 3x plus 5y equals negative 3. 2 times 3x is going to give me 6x. 2 times 5y is going to give me 10y. And 2 times negative 3 is going to give me negative 6. When I take negative 5 times negative 7x plus 2y equals 7, I end up with negative 5 times negative 7x giving me 35x. Negative 5 times 2y giving me negative 10y. And negative 5 times positive 7 giving me negative 35. Now I'm going to add those two together, and it looks like the y's are what are going to be eliminated. 6x plus 35x is 41x. Negative 6 minus 35 is negative 41. So 41x equals negative 41. Divide both sides by 41. X equals negative 1. If I substitute x equals negative 1 into either of the original equations, I should be in good shape. So I'm going to choose the first equation, which is 3x plus 5y equals negative 3. 3 times negative 1 plus 5y equals negative 3. Negative 3 plus 5y equals negative 3. I'm going to add 3 to both sides, which gives me 5y equals 0. Divide by 5, y is equal to 0. The solution is negative 1, 0. Some things to remember. In example 5, we could eliminate x instead of y by multiplying the terms in the first equation by 7 and the terms in the second equation by 3. The solution will be the same. You can try this yourself if you want to confirm that method.